All right, I think it's time for us to get started. Hello, everybody, and welcome to this talk. My name is Oleg Zhurakousky. I am, who am I? I've been with Spring since I'm one of the, I will like to call myself one of the original ones. I've been with Spring since 2008. Started as kind of everybody else started in Spring, doing pretty much everything there is to do. Eventually migrated to as an engineer in Spring integration, and fast forwarding, right now I'm a project lead for Spring Cloud Function and Spring Cloud Stream. And today we're going to talk about Spring Cloud Function, of course, and some of the new innovation that's going on within Spring Cloud Function, specifically around Spring Web controllers and how it works in serverless environments. So our agenda, for this presentation, I'm declared as a single speaker, but I will use the opportunity to bring my colleague from AWS team, Mark Sales, who will help us out describing some of the things that are related to AWS a little bit later. So our agenda for today is kind of very simple. So I'm going to quickly introduce you to Spring Cloud Function. Then we're going to talk about the concept of a serverless, and then touch a little bit on the controllers and kind of bring this whole thing together, why these three things are relevant in the context of this talk and in the context of something that you may decide to do later on. So quick show of hands, how many of you are using Spring Cloud Function today or familiar with it? Okay, 1, 2, 3, which is great because now, well, 4, 5, you know. So I will give you a quick introduction of what that is, and then we'll go further. So Spring Cloud Function is basically a very simple framework in a way that it promotes the development of functionality using Spring Cloud, or using Java functions. So Java functions, this is a function, supplier, and consumer. The ones, the three interfaces that were introduced with Java 8. So let me ask you a rhetorical question. If you, obviously you're familiar with these interfaces, right? So what requirement of past, present, or future can you not implement using one of those three interfaces? It's something to think about. Obviously, there's nothing that you can think of that could not fit into one of these three interfaces. If you do, the benefit is that now a framework like Spring Cloud Function could take your functional requirement that you implemented absolutely independently from the execution context and turn it into that execution context. For example, a function, here's an example of a Spring Cloud Function application, right? So you see a very typical Spring Boot application with a single bean of type function, you know, that will uppercase the string. Obviously, the example is very trivial, but the code that goes into function, that's entirely up to you. We don't really care. We only care about the signature for the purpose of type translation and other things that adapters will do. But the point is that this function right now is just a plain function. But without changing the code, this function could become AWS Lambda, Azure function, stream handler, REST endpoint, and many, many other things based on the adapters that we provide within Spring Cloud Function. So right off the bat, we're going to go straight into the demo. So I am going to, I will post the links for the demos are going to be in the last slide. So I have this project, and this is my function configuration. So you can see, you guys see the code, right? Can you read it? Fonts are not good enough, big enough? Right, so again, I'm using a very trivial code. I mean, if I spend the entire, I could spend 2 hours just describing Spring Cloud Function and all its features. So right now, I just want to show you that this particular function could take on many different phases. So for example, right now, you don't see what this application will do other than it's going to uppercase the string, but where the actual value is going to come in. In order for us to do that, we need to look at the pump file, because the pump file will tell us more, because obviously we're using Spring Boot, and with Spring Boot we have the concept of auto configurations, and right here you can see that I have this dependency, Spring Cloud Stream Binder Rabbit and Spring Cloud Function Web. What does this dependency give me? The first one says, listen, I'm going to use a messaging application. I want to make it, turn it into a messaging application that will use RabbitMQ, right? Spring Cloud Stream, which is another framework that I lead, use a Spring Cloud function as a programming model. Therefore, you don't need to explicitly import anything with regards to Spring Cloud function with regards to Spring Cloud Stream. Now, the second dependency is Spring Cloud function web. Obviously, this is just for the demo purposes because I want to be able to expose this function also as a REST endpoint. So let's see how it works. So all I need to do, like I said, the code doesn't change. All I need to do is basically start the app with these two dependencies. Ooh, what did I do? That's not what I wanted to do. And now I can go to command line and do curl uppercase Oleg, and all of a sudden you can see that my string was uppercased because the function actually acted as a REST endpoint without any kind of complex configurations required from you, right? I can also go to RabbitMQ console. You can see that the queue was created for uppercase, and I can submit hello world, publish message, and we can see this as uppercasing hello world, right? So that's pretty much the gist of Spring Cloud function. Of course, there's much more to talk about this, and there's plenty of online material that I've presented in the past that you can find, that's kind of the gist of it. By the way, if anybody has any questions, don't wait till the end. If the question is in context, it's much easier for me to answer, so just raise your hand, and I will try to answer it the best way I can. All right, going back to the presentation. So, not play from start, sorry. Oh, what did I do? Play from current slide. Okay, so, all right, so in summary, Spring Cloud function instruments Java functions for a variety of runtimes, so a single function could take on many different faces. Serverless. So serverless is, again, very, well, interesting concept because also the very sort of misleading terminology because we can't get away from servers. They're always there, just that it's a question of do we manage them ourselves or do we delegate to platforms such as AWS Lambda to do it for us in whatever way they decide to do it, right? So it's infrastructure managed by a provider, it's event-driven, events trigger functions, and functions are stateless and short-lived. That's the natural sort of microservices model. Pay-per-use pay-per-use as the billing model, scalability, and all these other great features that comes with serverless. So providers, there are many, but the leading ones are, of course, AWS Lambda, Microsoft Azure, Google Cloud Functions, and so on. So this is the sort of a graphical representation of how, for example, a single function, and I'll show it to you again as a part of the demo, how a single function can work, well, it does work in AWS Lambda. So, for example, especially with attached gateway, API gateway. How many of you, by the way, are using AWS Lambda today? All right, quite a few. So you're familiar with API gateway. So in other words, when you deploy AWS Lambda, when you deploy AWS Lambda, for lack of a better terminology, it's just there, right? So you need to create some type of, you can test it with a, AWS dashboard. You can do the same thing in Microsoft and Google Cloud, but the point is that while it's by itself, it's just there. So you need to expose it to the outside world. API gateway is one of the ways to, HTTP API gateway is one of the ways to expose AWS Lambda to the outside world. And in this case, what you see is that user invokes HTTP endpoint that was created by, exposed via API gateway, and then that in turn invokes function via provided Spring Cloud function adapter. So again, I provide samples for that, and my samples include the SAM template file for deployment purposes. For those of you who are using AWS already, you're familiar with this SAM, which is a serverless application model. Yeah. So it's just a nice way for the developers to quickly deploy to configure various different parameters. Or you can actually go through the dashboard, click, and do it the same way. All right, so demo. So again, for the sake of saving time, I've already deployed, so let me just show you how things are working. So for example, that same application, typically what I would do, like I showed you the PUM file, this is just for an initial demo, but typically what I would do, I would expose this dependency, which as you can see, it's Spring Cloud Function adapter AWS, right? Which again is auto configuration and will do all things that are necessary for you to deploy this function as AWS Lambda. And then you have this template file, which provides SAM template file, which provides, again, this is sort of a standard thing for AWS, so guys who are using AWS daily are familiar with that. It's just a few configurations there. One, the important one is the function invoker. This is actually what acts as AWS Lambda, because that's the main endpoint. It's always the same, no matter how many functions you have, 1 or 20, or you always provide you always point to the single function invoker, which is basically a component that by definition invokes your function. So with regards to AWS, it acts as AWS Lambda, but with regards to your application, it acts as a delegate to invoke your application. So that's why it's called function invoker. And then, there's a API gateway configurations there as well. So all we need to do is SAM build, SAM deploy, execute 2 commands, and it will be deployed. So thankfully, I already did that, again, because we're dealing with a lot of network resources, so I just wanted to be safe and don't blame the demo gods, so I already deployed it. So here is AWS dashboard, right, Mark? That's how you call it? So here's an AWS dashboard, and here's a function. I can just go into the test tab and basically invoke it from here. And it's chugging along, finally got invoked, and I can look at the output. It's uppercased my name. Okay? Any questions so far? Now, how many of you noticed a little bit of a latency during me invoking it? You did, right? So obviously this is really not good. In fact, if I try to do it again, you can see it's pretty much instantaneous, right? So we're going to talk about this in a few minutes. So, but this is basically shows you that, again, the same function that you just saw as a REST endpoint, the same function you just saw as a streaming handler for the messaging application, has also became AWS Lambda without me touching any piece of code other than providing different types of dependency, different auto configurations. Okay. Finally, we are in why we're here today. So, controllers. How many of you, yes?
So the code that you deployed in the Lambda, is that a zip file, like a package?
So the question was, the code that I deployed to AWS Lambda, is it a zip file or a jar file, right? So yes, it is. So in other words, if I execute like maven clean install, there is another configuration. Actually, let me show it to you. Good question. I'm glad you asked this. So there's more configuration to that. So in the PUM file, you can see there is a few plugins that are present. Okay. And again, there's a bunch of examples within Spring Cloud Function. When you go on GitHub, where is it? If you go to GitHub Spring Cloud Function, you'll go to samples, and you see a bunch of different AWS samples. So in other words, you can quickly get started. So yes, the plugin. So if you execute maven clean install, it will generate the zip file that you deploy to AWS Lambda. Or if you do the SAM build, SAM deploy, you don't have to do anything. It will do all the things for you automatically. So, but yes, you have to package it to deploy it to AWS Lambda. I'm glad you asked. So. All clear. All right, controllers. So as I mentioned during the keynote, I use the word controller sort of loosely to refer to Spring programming model to deal with web workloads, right? So how many of you use Spring MVC, Spring Web Frameworks? All right, so you're familiar with this code, right? So that's, again, the code here is sort of trivial, but at least it gives you a bit of a feeling that of a typical Spring web application. as I also mentioned during the keynote, is that typically these type of workloads live on servers, right? Application servers that we as a developers sometimes putting on a different hat as operations people. Now we have to manage, maintain, estimate, procure, do all these different things that is there anybody who likes doing that here? All right, not a single hand, just for the record. So, so we don't like to do that. Thank God there's other people like Mark and people who work for AWS and Azure, whatever, they like to do that for us, so that's great. So, so the point is that Spring provided you, the developers, various different ways to optimize your work. In other words, historically, we handle boilerplate code. You only worry about functional requirements. We were kind of missing this for the infrastructure piece because we still had to, while we're kind of been satisfied with Spring when it comes to the development concerns, when it comes to infrastructure, we didn't really have anything. So, however, serverless provided us with that same capability that Spring provides for the developers. Serverless and platforms such as AWS Lambda, for example, did provide us with the capability to address these boilerplate issues on the infrastructure side. And to talk more about this, especially with the context of AWS Lambda, I'd like to welcome my colleague on the other side, Mark Sales.
Hi, Oleg. Thank you very much. It's been really cool to be invited here and to speak to you, so I really appreciate that. I saw that some people had already used AWS Lambda, but it's really cool just to give a brief explanation of what AWS Lambda is. So AWS Lambda is a fully managed compute platform. So when I say fully managed, you don't have to create any virtual machines, any servers to run the code that Oleg's been showing. So you upload your zip file, and as the traffic comes in, we are going to create places for that code to execute. So behind the scenes, we're going to find a spare bare metal host. We're going to create a virtual machine on that host. We're going to put your code onto that machine, and then we're going to execute it. And that might sound quite heavy, but we can do all of that in about 50 milliseconds. So it's very, very easy for us to flex the capacity that we have and to give it to various different customers. And that's the way that we can reduce carbon footprint and lower the costs for people using the platform.
This is great, Mark, but what about the serverless, the controllers, the whole thing that we're talking about?
Yeah, so what we want to be able to do is not just take a new application like a Spring Cloud Function, but we want to take existing applications that you all have that are running on Spring MVC and Spring Web, and we want to be able to basically work with them in the same way that Spring Cloud Function is. So we want to take that request as a HTTP request and basically just handle it in the same way as a Spring Cloud Function, and that's what we're doing. So we've got a project called Serverless Java Container that we're working together on, and we're taking a request that comes in from a HTTP request, and under the hood,
yeah, I'll do the slides.
Under the hood, the AWS side is converting it into a common Java object, and then we're passing it basically to Oleg, and Oleg is writing the functionality that then turns that request and handles a Spring Web Spring controller. Right.
So in other words, like I was saying during the keynote, AWS guys do live in their domain, we live in our domain. They're the best experts in AWS, we're the best experts in Spring. So what happens is that they receive the request, as you see from a diagram, they receive the request in the form of a JSON. That's what it comes in, for example, from API Gateway. So they convert that JSON into HTTP servlet request, and then we delegate it. Then they delegate it to the code provided by Spring Cloud Function to handle, to interact with the dispatcher servlet. Effectively, what we're doing on the Spring side, we turn dispatcher servlet into sort of a function itself, right? And then we send back the HTTP servlet response, which they convert and turn back to the JSON or whatever else. We don't really know, we all care, because that's how we separate responsibility with regards to this. So, we'd like to sort of announce, I guess, that since version 2 of AWS Serverless Java Container, This is already being committed, so in other words, so version 2 of AWS, so right now it's M2, right?
Yeah,
Yeah,
available now.
So milestone 2, but once it's merged as a release, you can basically by importing, and I'll show it to you in the demo in a second, by simply creating dependency for AWS serverless Java container, you effectively will see Sprinkler function on the class path because that's what AWS serverless Java container is using. And yeah, so now Mark, I have a question about this. So we kind of touched upon it during the keynote, but obviously when it comes to you know, serverless platforms such as AWS Lambda, there's a great benefit of, we talked about the scaling. So it's not just about your application completely down, like goes in suspension mode. What about if there's a spike, right? So like we need to create those new instances. But the problem, as we already saw, the cold start, right? So when you try to start up a new instance of application, I mean, you obviously saw it took about almost 3 seconds plus, right? So what can you offer us?
Yeah, absolutely. So we don't want to have that increased latency as we're creating new execution environments to run your code. So what we have is a new feature, and it's called Lambda Snap Start. And I don't know if is anyone familiar with Project Crack? So Project Crack is coordinated restore at checkpoint, and it's basically a way of checkpointing your function. So we're going to take your Lambda function, we're going to start it up. Once it's started, we're going to take a snapshot of that entire virtual machine. So not just the JVM, but any files, any processes that are on that machine. We're going to take a copy of that image, we're going to encrypt it with your key if you want to, and then it's going to be put into storage. We're then going to take that image, put it into a whole heap of multi-tiered caches so that then we can create execution environments from that cached image, and we can do that restore process up to 10 times faster than creating a normal Lambda function. So we get much snappier results for those sorts of web requests where we don't want increased latency. SnapStart is free, so there's no additional cost for this capability. We take it all. It is only available for Java 11 and 17 though, so if you're on Java 8, you need to move up to 11 or 17 to...
That's our way of forcing you to move on. Right. There were some questions, Mark.
That's it.
I was curious, earlier when you were clicking the test button and it got better, at what point does it revert back? I don't know if it uploads it or what, but how many executions like that do you get the performance still and then it goes back to?
So it's non-deterministic, unfortunately. So behind the scenes, we're always trying to balance capacity and give you the best performance possible, but we have to balance that up with price, cost, performance. So there's no real way of knowing. If you keep using that function, we're going to give you the best performance we can. And as you get more traffic and more concurrency, we'll create more. But as you stop using that function, we're going to slip out some of those execution environments.
So yeah, crack would be better for that purpose.
Yes.
Do you have to use crack on every execution? How does that work?
So
I would, if I may interfere. So first of all, let's separate the crack and SnapStart, because SnapStart is not crack, right? SnapStart actually came before crack, so to speak, meaning that SnapStart is, correct me Mark if I'm wrong, but SnapStart is it's a solution provided by AWS for AWS within AWS environment. However, with relation to crack, SnapStart does support crack hooks, which is the only hook, which is the resource interface, right? So if you put the crack on the class path and you provide implementation of the resource interface, it will invoke it. So in other words, you can still use SnapStart with crack, but SnapStart by itself does not require crack, nor it is crack.
Yeah, and some of the awkwardnesses of crack, like you have to shut down all the network connections and file handlers, that's done automatically as part of the managed platform. So it's a very easy onboarding process. You upload your zip file, we create the image, and then after that, all of the execution environments are created from that image automatically. And all the storage of the image is all managed.
There was another question?
Can you help me understand for a web application, how is this adding more advantage over, say, a user-defined autoscaling?
Because you don't know what the traffic profile of your traffic is. So you can define it as much as you like, but someone from marketing puts out a rogue marketing campaign, and your auto-scaling gets blown up. So by default, you can scale from 0 to 3,000 execution environments. Each of those execution environments can have 10 vCPUs and I think 10 or 12 gigabytes of memory. So there's an enormous amount of capacity that you can have by default, and each of those execution environments can handle many requests per second. So you can think of how much capacity you get from default. If you need more than that, it's a ticket to support, and they'll raise your limits.
It's like when we mentioned during the keynote, I mean, okay, so you're done estimating your servers, you procure the servers, but then while you're doing this process, it's not an instantaneous process. By the time you're done with this process, your requirement change, your business boomed or picking up, right? So now all of a sudden you need more servers. So you need to constantly worry about this, constantly adjust, where with serverless platforms such as AWS Lambda, you don't need to do that.
If there's a mistake in the scaling, or the scaling is always difficult because your scaling is only as good as how fast your application starts up and how much spare capacity you need while your platform is scaling. So if your application takes a minute to get a new server and be healthy from that server, then you need 50% of capacity ready to handle that while you add more capacity. We can create a new execution environment in 100 milliseconds.
All right, go ahead. One more question.
Yeah, sorry. According to, so regarding SnapStart, there's a plan to support that for image-based lambdas?
Oh, for container images?
Yes.
Yeah, it's something we're looking at, and we'd love to chat more about how we could do that together.
Right.
Not available yet, but on the cards.
All right, and also before I do the quick demo, I also wanted to mention that aside from AWS SnapStart and Crack, the other way of scaling within the AWS Lambda and or other platforms is to compile to native, because that's another way of increasing your startup time. All right, Mark, thank you very much for your, maybe you can hang on with me while I do the demo for the, so what we're going to do right now is I'm going to show you a couple of demos for, we're going to show the SnapStart, which is, because of the indeterministic nature, it's not very easy to demonstrate. So Mark will help me to explain what actually, what we did. And I will also show you how that controller that, first of all, that's a different application. So let me show you the code. So again, it's an example that's provided as part of this presentation, so the link is in the last slide. But, so I'm going to start with actually a controller to show you that the controller was deployed in AWS Lambda, and you can invoke it and interact with it. So I just want to quickly run you through the code. So it's it's kind of an imitation of a pet clinic, pet store, however you want to call it. So we have application, Spring application. So we have typical Spring Boot application with import various different configuration. Again, it's completely irrelevant because there is nothing here that is specific to either AWS Lambda or Spring Cloud Function or anything else. It's your typical Spring MVC app with whatever configurations you had there, right? So you can see pet controller, all this other great stuff that you would typically see in a Spring MVC application. Now, when you look at the pump file, this is what's important. So you can see this dependency, right? So I can change it probably to M2, but I'm not going to do it right now because we're the demo, right? But I don't want to download the internet. But so I'm not depending here on Spring Cloud Function directly. I'm basically importing Spring Serverless Java Container for Spring Boot 3. And that in turn will bring Spring Cloud Function into the class path, and when it's all deployed, we're going to be able to interact with this application via API gateway as if it was running locally on Tomcat or Jetty or something along those lines. So again, it's been already deployed. So if I go to my functions, you can see pet store boot 3, so it's been deployed with the API gateway. So now I can go to command line, and so you can see my curl command just goes to AWS. I can do the first one, pets, right? And again, we see the cold start thing here. So my next request is going to be much faster. I can do pets with ID, and it's going to pull a single pet and so on and so forth. So I can do posts, and I can do many different things with it, right? So in other words, our controller right now is acting So in other words, we have a Spring MVC app, but it's deployed in AWS Lambda, and all the good things that Mark was just describing you, that you can get, the benefits you can get from AWS Lambda, you're getting with this Spring MVC app. Now, what I also wanted to point out quickly before I move to another demo, another few things, is that Mark mentioned that, yes, there is a lot of, like in other words, earlier you saw how a typical Spring Cloud typical function was exposed as a REST endpoint. And yes, you could expose this function as via API gateway when it's deployed in AWS. So what's the difference by either writing a function or writing controllers and basically Spring MVC app? Well, there's two things. One that Mark mentioned, because there is much more Spring MVC apps out there than it is Spring Cloud Function apps, because of naturally, Spring MVC is one of the original Spring web development models, so there's hundreds of thousands of Spring MVC apps out there, where Spring Cloud Function is fairly new, even though it's been around for like, what, 4 or 5 years, but in terms of a mainstream. So that's argument number one. Argument number two, I get this request all the time. People say, oh, Spring Cloud Function, so cool, I can take a function, make it a REST endpoint without doing anything. Can you add this feature? Can you add this feature? Can you add this feature? I'm like, well, wait a second, I'm not going to compete with my own framework, with one of our own frameworks, right? I'm not going to put Spring Cloud Function in direct competition with Spring MVC, right? So if you have just a very simple requirement where you have functionality and you want to expose via the web, sure, write a function and add Spring Cloud Function web to the class path, and now it's a REST endpoint. But if you want to benefit from all this complex and featureful configurations that Spring MVC provides with the type conversion, with the complex type conversion, request parameter mappings, and all this other validation, and so on and so forth, then you can actually say, okay, I'm going to choose to write Spring MVC app, yet I'm still going to choose to deploy it in AWS Lambda. So it doesn't have to be an existing app, it could be a current app. So decision up to you. So we give you options, you choose what you wanted to do. Okay? Yes? Good question. So is it going to work for Webflux too? We don't know yet. That's the answer. The reason being is that the source, the API gateway, is the blocking. So in other words, the source from where the request comes in is the blocking. So we have the same problem in Spring Cloud Stream, where we support reactive functions, and I regret that I added it because people start asking all these different questions, and I'm like, we're dealing with a non-reactive binder. So when you're using reactive API, when you're implementing a function, you're basically only benefiting a little bit from the API itself, but you're not really benefiting from any reactive features until we actually have reactive sources. Like right now, on the Stream side, we have reactive Kafka binder, but that's just a matter of different discussions. So that's what it would make sense, but yeah, that's the answer to the question. All right, so now we talked about Spring Cloud Function, we talked about REST control, so now let's show about SnapStart, right? So this is like one of the more difficult demos, even though it will look kind of simple, but in terms of preparing it, it's a bit more complex. So you can see we have this uppercase function, right? That's the one that I deployed, that I ran locally, so I just changed the class path and to use AWS Lambda. And what you see here also is on the dashboard is this tab called versions, right? And what, Mark, can you explain about this, like what exactly we're doing here with regards to versions, like and why we're doing that?
Yeah, so versions are basically just like you would probably assume. It's a immutable copy of a function in time, so all of the configuration for a function and is then immutable, and SnapStart is only available when you use versions.
Right. So basically we have two versions, one for SnapStart with SnapStart enabled, one without SnapStart enabled. So I'm going to first use the one that has SnapStart disabled, okay? So here's the one without a SnapStart. So I'm going to go to the Test tab, Oleg, and 1, 2, 3, and we got it, right? Now I'm going to go to version with a SnapStart. I'm going to go to the test, and it's done. Much faster. So if we look at the parameters here, you can see the restore duration. Right? If I try to execute it again, you will not see that anymore, because now if I also go to the logs in the CloudWatch, I can see that how many milliseconds it took to restore this function, right? So it's being, so in other words, once we created a version, the function itself was already snapshotted, so now it was available out there, so whenever we had to hit the new instance, it was restored from the snapshot. So now I can hit it again, and it's going to behave the same way like before, instantaneous, because now it's already being warmed up, right? So the whole thing about difficulty demonstrating it is because right now it's warmed up. If I need to demo it again, I need to create a new version of it to show how the cold start works with the snap start. So Mark, thank you very much for helping us out with this. We only have a few more slides, and I have one extra thing to show you. So let's go back to the slide. So we literally, oh, go ahead.
Can you enable Snap Start with the Spring Cloud function?
Yeah, Snap Start has nothing to do with what's running. It's just in fact, it doesn't even require Java, right? Just Java, okay. So, but Snap Start doesn't care about Spring Cloud function or Spring Cloud or controllers because it has nothing to do with the underlying code. It just, it literally has to do with the JVM, right? So it's am I correct?
The whole execution environment.
Yeah, execution, yeah. So yeah, the answer is yes. Now Microsoft, same thing. So they have a different way of auto-scaling. Kubernetes event-driven autoscaling, which is SCADA, right? Works with many cloud providers, including AWS. A few examples you can use SCADA to scale on, which is the Linux cron, and so on. So you can read from the slides. So again, my colleague from China, who is the Microsoft, gave me these slides. Unfortunately, he couldn't be here, so I'm just going to try to quickly go through this. So this is the dashboard where you can configure the autoscaler, and yeah, I cannot talk much about this, but you can obviously get from the slides that you can do a lot of the similar features in Azure that you can do in AWS. As Mark pointed out, for example, in AWS, things work automatically for you. Here you still have to do, in Azure, you have to do some configuration with regards to your scaling, right? And we only have 3 more minutes, so this is the last slide that I was talking to you about with regards to where the samples are. But before we go there, let me give you one more other demo. So how many of you are familiar with the Spring Initializer? Okay, good. Should be everybody almost. So like earlier, there was a questions about like how do I deploy, how do I create a new application with regards to AWS and so on. So obviously, you can always cut and paste the existing example, like I showed you in the GitHub, and start from there. But a lot of these things right now we do when we try to get started with any kind of Spring Boot-based application, we go to Initializer and we create sort of a template initial version of it, right? So what I've been working on basically on a few days before flying here. We discussed this for a long time, so I just decided to find time and do it. And I'm going to show you. It's not yet committed, but once I land back home, I'll submit a PR, and hopefully within a couple of weeks, we will have that in Spring Initializer. So, but I'm going to show it to you locally. So I'm going to start the Spring Initializer locally. And here's my initializer running on localhost. And now if I want to create AWS app, all you need to do is type AWS, and now you're going to have AWS Lambda or AWS Lambda Web, which is again, whether you want to use simple Spring Cloud function on AWS or whether you want to use add controllers in AWS. And let me just show you quickly. So I'm going to generate. And so the interesting thing here is that you see that template file that I showed you before, so it's going to create one for you. Obviously, there's going to be a README file that will show you what else you can do. Well, right now I didn't write anything in the template file because it's a work in progress, but the fact that it was created, that's already a good thing, right? And then obviously all the other things that you would expect in terms of dependency, like for example, oh, I did Gradle, so let me just do again to Maven. Well, anyway, the point is that there's going to be all the Maven dependency, like you don't have to worry about, especially the plugins. Those are the ones that are important because the order configuration for the Spring Cloud Function AWS are going to be there, but these Maven Shade plugin and all the other things are going to be there for you. All right. So I'm done. So thank you very much. There's a few questions, so go ahead.
So you're saying that that template file is basically the confirmation code?
No, template file is this. Is this guy. It's a SAM template file, so I should clarify. It's a template file for deployment, yeah.
Yeah.
Yeah. And you said confirmation code?
Cloud information.
Cloud, yeah, sorry, I misheard. Yeah, yeah, exactly. Any other questions?
Will this get generated for controller-based projects?
Yeah, so that's what I was showing. So you will have, when you type add dependency, you have AWS Lambda Web.
Will it also contain a template file?
Yeah, yeah. So it will contain everything for you to get started, right? So in other words, you can immediately import it into the workspace, and all you need to do is define, for example, for this case, you would need to define a single controller or multiple controllers. Or for Spring Cloud function, you just have to define at least one function bean, that's it.
So in case of controller, how does the handler know which one is the function?
How does the handler know? Oh, good question. So again, the template file. If you look at the template file within, this is the commit. This is the PR that went into Spring Cloud. Into AWS serverless Java container. So if you look at the template file for MVC, you can see. Remember, I showed you the function invoker for Spring Cloud function in the previous template. So this one is com.amazon.serverless proxy spring delegating Lambda container handler. So that's the container handler that's gonna work with, and from this point on, it simply delegates HTTP servlet requests to dispatcher servlet. And from that point on, Spring takes over and does whatever. Does the mapping, figures out which controller to invoke based on the HTTP servlet request. Guys, thank you very much. I'll hang out around there just in case if you have any more questions, but thank you very much, and thank you, Mark, for helping us out.